Hi, it's Naomi Andrack, and this video is on graphing vertical and horizontal lines. So when we look at the equations that go with these lines, they look a little bit different than a lot of linear equations because they just have one variable. So here I have x equals a number. Even if I had a different equation like x plus 7 equals a number, if it only has one variable, it's either going to be horizontal or vertical. And horizontal, we know, goes like the horizon from side to side, and vertical is the other way. It goes straight up and down. So this is a very specific type of line to graph, and it's one that's not really tedious or too much trouble to do. So I'm going to start doing this with a chart. We're going to move to where we're doing it without a chart pretty quickly because you'll find that you don't really need one, I expect. So here we have to look at the information that the equation gives us. All it tells us is that x has to be -2. So for all my points, x is going to have to be -2. It can't be anything else. Now, it doesn't tell me anything at all about y, though, right? So I could pick y to be whatever value I want. I could pick 1, 2, 3, 4. I could pick, -5, 0, 5. I could pick -102. I wouldn't pick -102 because it's not on my graph. So I want to make sure, since I get to pick my own values, I want to make sure they're nice, easy values to graph. If you have trouble with negative numbers, pick positive numbers. If you have trouble with positive numbers, pick negative numbers. I wouldn't pick fractions or anything like that. So now going from here, this is the point -2, 1 over on the graph. Let's see. -2 is going to be left 2. 1 is going to be up 1. So we go left 2, up 1. This is the point -2, 1. This next point, -2, 2. Oops. Here's -2, 1 right there. -2, 2 is going to be right here, directly above it. -2, 3 here is going to be over 2, up 3, right there. -2, 4 is going to be left 2, up 4. So we can see there are a lot of points that make this equation true. Y can pretty much be anything, right? And our graph wants to encompass all of those possible points that make this equation true. Y could be anything. So we can see, oh, well, these 4 points make it true. They're lining up in a vertical line. And any other point on this vertical line, like this point over here, -2, 9, well, that still makes x -2, so it's still a point that makes this equation true. So our graph would just go straight through all of the points where x is -2. And that would be the graph of this equation. Okay, let's go and do another one. So here's one. This one is y equal 4. So we know for all our points the y value will be 4. X values can be whatever we like. When I go to graph these points, let's see. 1, 4 is going to be right here. Oh, sorry. Right there. 2, 4 over 2, up 4 right there. That was beautiful. 3, 4 right there. 4, 4 right here. And so we see, oh, all these points line up in a horizontal line. Now, this will always be the case when you have y equals a number. It's always going to have the same height or y value for all your points, so it's going to be horizontal. That confuses some students because they're like, hey, the x-coordinate tells us how far over to go, the y-coordinate tells us how far up to go, so shouldn't the x be horizontal and the y be vertical? But if we have a constant height of 4, we're picking all these points where the height is 4, they line up horizontally. Whereas if we have a constant distance over, always the same, they're going to line up vertically. So let's do a couple more. We'll do them without the chart. So y equals -7. After, I know, see, height is always a -7. So I can just pick 2 points with a y value of -7. I've got the graph. And then with x equals 4, I just pick 2 points where the x value is 4, and I've got the graph. So hopefully you can generalize this and use it to graph horizontal and vertical lines accurately. Okay, I hope this helps. Bye.